Hey, so welcome everybody. My name's Colonel Abadie. I go by Dre if you see that anywhere. First off, I just want to say thanks for being here. Thanks for taking the trip. On behalf of our Army senior leaders, thanks for coming out here to see the joint experimentation in action. We're really happy to show what we can, but just have the conversation continue in terms of the pursuits that we're making. So who am I? So I work in Austin, Texas at the Army Futures Command headquarters. I think officially I'm a solutions architect for all things network, cyber, and artificial intelligence. But my role in this endeavor is about 2 years going now. So I had the privilege of being a leader in the planning and design of Project Convergence. And then as the plans shifted down to Joint Modernization Command and they took those ideas and turned them into action, I had the privilege of staying involved. So I'm going to share with you kind of the big picture, not just exactly what's been happening, but kind of the context upon which it all built. So Army Futures Command, for those of you who aren't aware, Army Futures Command stood up a little over 3 years ago. Its purpose was to drive acceleration and progress for the Army's 6 modernization priorities. And in doing so, approximately 4 years ago, so just a year before, we stood up what we called cross-functional teams. And those cross-functional teams were aligned against those modernization priorities. And so a cross-functional team has a really interesting role, almost as an integrator. So they have left and right limits in terms of what they do. The left limit is our concepts and the way we visualize fighting in the future. And the right limit is the requirements document, the way we codify and have our leadership approve a requirement. At that point, our teammates in the acquisition world take those requirements and then field capabilities and deliver capabilities to our units. The Army has 31 plus 4 signature modernization efforts. And so those things happen in a temporal fashion. And so when we talk about Project Convergence, it's the idea of how do I identify the technologies that will enable the concepts? And I have to look at a list of candidate technologies and understand which ones are mature enough to actually come out here in the dirt and experiment with. And so we have some capabilities that are going to field in 23 and 24. We have others that'll be 28 and beyond. So there's some things you just can't experiment with, they're just too immature. But the idea is the sooner we can bring things out here, get them in the dirt, get them in soldiers' hands, the sooner we can learn and we can inform those concepts and we can inform those requirements documents. The idea is to have them out here, have them demonstrated, and then our acquisition partners can help pull them across that infamous valley of death and help that procurement cycle really realize technologies faster and accelerate the way we deliver to the force. So quick history is, what is Project Convergence? So the original idea, almost 3 years ago, was the Chief of Staff of the Army giving guidance to AFC leadership that we need to make sure that as these cross-functional teams start to develop modernization capabilities, they're not doing it in stovepipes. We're not siloing these efforts. So the Chief was pretty clear about you will integrate as early as possible and ensure that integration happens throughout the capability development process. There was also an original spirit to it though. So as the cross-functional teams took on that task of the first Project Convergence, there was a spirit of, okay, well, it's one thing to integrate across warfighting functions and ensure that we can fight as a combined arms team and as a joint team. It's another thing for us to recognize, how do we integrate emerging technologies? How do I capitalize on artificial intelligence, robotics, autonomy? And how do I show the value of those technologies? How do I prove that I can integrate them in the way we fight and that they will have value that's important for our leaders to recognize? So there was that spirit combined with this idea of integration that was really important to how PC kind of stood up. There's a couple of ways you can look at what Project Convergence means to the Army. So first and foremost, and I'm sure you've seen it, it's a campaign of learning. And so this is not a 1 year, now it's 2 years, and we're done kind of thing. Our leaders have said they see this to probably be a decade-long endeavor. And as a campaign of learning, it means that every action we take needs to build upon something else, inform something else, and allow us to continue to get better. So you're out here now seeing the culmination of about 7 weeks of experimentation, but there's been over 24 events that have happened prior to this that led up to these experiments and that made us prepare things better to continue that learning process. As a campaign of learning, we're trying to inform concepts as well. So as you know, the joint warfighting concept was recently approved. There's another one in draft. So we're informing that. We're going to take lessons from these experiments, give them to our leadership, give them to the joint staff, and allow them to see where that fits in terms of the direction of the force. We're doing the same thing for the Army's concept. So the multi-domain operations concept is currently transitioning to doctrine, and therefore they're going to already start looking after what is next for the Army in terms of how they fit into the joint force. So we're trying to inform those concepts. We're also informing Joint All-Domain Command and Control. And so as we track the way the joint staff is leading that effort and how they are developing and implementing the JADC2 strategy, then we're trying to inform that. And I'll talk about that a little better later, because we had some great moments and we got some great support from the joint staff. Project Convergence is also a vehicle for collaboration. So all the services are out here today. We have DARPA out here. Next year we'll have coalition partners. And so it's this idea, again, we go back to this thought of integration. You know, the Army doesn't fight alone, and generally we don't fight at home either. So we need to work the ability to partner. And so therefore, collaboration is key. Project Convergence 21 and the things that you'll see could have never happened if it weren't for the joint partners coming together and truly collaborating, truly buying into this idea of learning, this idea of experimenting, and this idea of discovering what's in the realm of possible. There's also a great deal of fidelity and rigor that we're trying to reach here. So we've had over 300 data collectors out as part of all these experiments, looking at telemetry, instrumentation of these technologies. The idea is we need to get beyond these demonstrations where we just blow things up and we do high fives and we walk away and everybody's happy. In all honesty, we need to have empirical data that informs senior leader decisions. It needs to be irrefutable, and if it's not irrefutable, it at least needs to be repeatable. And so that's been something that we've tried to bring to ensure the necessary fidelity and rigor in the initial observations, the insights, the findings that will come out of this experiment can stand on their own and inform what we do next, so we can continue to build off of that lesson. And then I think the last thing I would share with you is Project Convergence is not just about learning, but it's about documenting that. You know, how do I take these lessons and codify them so they go beyond just one presentation, one senior leader brief, etc. And so we go back to these idea of requirements documents. And so am I actually codifying what we learned? Do leaders agree with what we think we just see as part of the future? And therefore you have to codify it in that requirements document, because that's the only way it's going to become part of that capability in the future. We had an original 3-year strategy, subject to change because we are continuously learning, but it was starting off last year, so we call that PC20, fairly land-centric, okay? But the intent was 21 was to be all about driving joint integration. And then the idea is moving to 22, we get to this 3rd year, we will involve our coalition partners, and we'll start to expand it to ensure that Project Convergence is an experiment that accurately reflects the way we fight as a joint force, as a combined coalition force. So PC20, just to give you a quick touch. So PC20 happened last year, roughly September of 2020 here at Yuma Proving Grounds. Very land-centric. The focus was how do we enhance the close fight, but it wasn't just the Army. It was the Army, it was the Marines, it was Special Operations Forces. We framed it with the Army's concept for the future, which is multi-domain operations. We specifically took 3 phases of multi-domain operations and worked through the experiments to see how these new technologies could inform the fight. And so the first phase was penetrate, this idea of the A2AD, area access anti-denial, or anti-access area denial. How do we penetrate that? Then you move on to this idea of disaggregation. How do we target enemy air defense systems, enemy long-range artillery, in order to start dispersing their forces and providing windows of opportunity to exploit that advantage? And so that 3rd phase is exploit. Now we get into decisive land maneuver. How do we take advantage of that opportunity and capitalize on it? So we found PC20 to be a pretty significant success, But again, it was about learning. It's about what do we do next. So as we moved into PC21, it was joint by design from the beginning, okay? And so a couple of things happened to really enable that reality. First, my boss, Lieutenant General Jim Richardson, who's the Deputy Commanding General of Army Futures Command, established a joint board of directors at the 3-star level. And so it had members of the Army staff, it had members of the Air staff, the Naval staff, it had the Commanding General of the Marine Corps Combat Development Command, we had the J6, the J7, the JAIC director. And so every month, as we planned everything that's happened over the last 7 weeks, we had joint leaders coming together to ensure there was consensus. There was consensus on the objectives. There was consensus on what we call use cases. So how did we frame scenarios in order to ensure the experiment accurately reflected the way we fight? There was consensus for the data collection and make sure we're capturing what every service leader wants to see when we have findings in the end. And it was consensus about the basis approach. So no changes occurred without those leaders being consulted and ensuring that we were still going down a path that met their desires. The big piece that I think what I would say is pretty critical is we need to have partnership with the J6 and J7. So the J7 who drives concepts at the Joint Staff level, ensuring that we stayed on path of what they wanted to see. The J6 as one of the leaders of JADC2, ensuring we stay on path in terms of how we can inform their efforts and progress those efforts. So that joint board of directors was absolutely critical. And again, collaboration has been the secret of our success. Another piece that we learned the hard way is communications is difficult. Networks are difficult. So last year, we started putting things together out here in the desert. It's 120-something degrees. It was miserable. And we learned that when you try to integrate technologies that weren't meant to come together, it's pretty difficult. And in that kind of heat, it's pretty miserable. And you know, when you look at what JADC2 espouses, this idea of how to sense, make sense, and act, it's also talking about this idea of moving away from kill chains to kill webs. And when you say that, it kind of rolls off the tongue, but what you don't realize is most of these kill chains, if you will, is an exquisite requirement that was documented, designed, and built to do exactly what it does. That's why it's a single sensor informing a single shooter, going through usually a single C2 node. It does exactly what we asked it to do on some requirement document so many years ago. And so the minute I started asking, well, can I take 2 other sensors and make it inform that shooter? I'm doing something it wasn't designed to do. And that's pretty hard. Now that's really the essence of what JADC2 means to be, but if you're a network designer, configuration manager, I've just given you a problem that's almost impossible. And so we stood up a joint systems integration lab at Aberdeen Proving Grounds. And we said the entire ramp up before we get out here in the desert, as you see now, we will go through a series of communication exercises, a series of rehearsals, and every piece of technology, we had over 110 technologies out here, we'll go through that integration lab so we can see how it works. We're not going to find out the hard way when we come out in the desert to experiment that these things don't connect. And so that was absolutely priceless in terms of this success out here. Did everything work? No, it still didn't. I mean, it's the network, it doesn't work. But we had the right leaders out here to drive significant progress for what the network can be. And we had leaders that were flexible enough to accept change. You know, I can design a network and tell you it's going to be perfect, and then someone's going to bring a new technology in. I can either tell them no, or I can say, you know what, that's a really interesting technology, and I really want to see what it means to the fight, so let's integrate it in what we're doing. And so we went through some of those challenges, but there was nothing but value coming out of that. So what did we do out here? So we were informed by the combatant commands, and specifically INDOPACOM. So we used a scenario of INDOPACOM. We were hoping to the best of our ability to replicate to some degree the tyranny of distance, which is part of that theater. There's probably a half a dozen, if not more, CONUS-based locations that were part of what we were doing in this experimentation. And so you'd start to see that stressing the boundaries of what can and cannot happen over distances. But what the combatant commanders told us is operational scenarios that made sense to them. Okay, so we used 7 scenarios for our experimentation. The first scenario is kind of this idea of the joint force in competition. And it's how do we maintain joint all-domain situational awareness? How do we collect the information in our daily activities and inform leaders, specifically a joint force commander, on the situation at hand? How do we prepare them that if deterrence fails, they're prepared for conflict? Now, we did that with our naval partners, replicating a surface action group. We had Marine partners replicating a Marine Littoral Regiment. We had Special Operation Forces. And then we had the Army's Multi-Domain Task Force. And so this idea of joint all-domain situational awareness kind of starts with, do I have a joint common operating picture, a joint COP? We're struggling there, okay? So we found some challenges with this idea of how do we, as services, share information and maintain a single view of what that common operational picture will look like. We worked through that. We started to push a little bit, and we'll see what the Joint Staff has with the feedback we gave them. But I will tell you, again, I've seen a couple articles with General Kroll, this idea of we're moving towards action now for JADC2. It's not necessarily about planning or talking, we're moving to action. We reached out to the Joint Staff, we told them some of the things we had learned about this idea of a joint COP, where we were not necessarily able to connect, and the Joint Staff sent a team out here immediately. Sent a team out here to sit down with the operators, sent a team to sit down at the systems where we could say, hey, here's the message formats, these are all joint message series, but when the Navy uses it, they do this, when the Marines use it, it does this, when the Army uses it, it does this. If you would add these three fields, we can all do this in a coherent way together. So they spent a couple days out here, lots of documentation, lots of observation, and they took that back for action. And so we're hoping to see that in a future experiment, we can take whatever output the Joint Staff gives us with these new message formats and then do the experiment again and see if we can bridge the gaps we had. So, joint all-domain situational awareness. So in our scenario, we have a kind of a red line tripped, and we have incoming ballistic missiles. And so now we enter this idea of joint air and missile defense. I'm sure most of you are familiar, but all the services do this pretty well. So the Navy has the ability to do protection, air missile defense. The Army has the integrated AMAD Battle Command System, IBCS. We have a series of abilities to use space assets to detect these things, et cetera. But we kind of played with the idea of, okay, well, there's two missiles. Who shoots them? How do we decide? How do we coordinate? How do we coordinate at the speed of that threat? Air missile defense is probably the most difficult thing to do, at least from a network standpoint, because of the real strict latency measures and the ability to maintain an idea of that target you're trying to engage. And so I would say openly, if it's over the water, the Navy knows they're the ones who shoot it down. If it's over the land, maybe the Army knows they're the ones that shoot it down. But if I'm on an island, is it maybe confusing? I don't know. I mean, I'm sure there's processes and procedures, but we just wanted to play with that idea. And that idea of, can we link the services together? Can we work through something to where they can share that information and we can go back to a lesson we had in PC20. How do I go from all sensors to the best shooter? How do I leverage these emerging technologies to identify which service is the best to engage the threat? And then there's some level of direction to which one does that engagement. So we're really excited about that. Again, progress was made, more things to share with the Joint Staff, and we have, each service has its own fire control net, and we just need to explore a little further how we can potentially tie those things together. That's a difficult task. Again, like I said, there's a latency issue in terms of the sensitivity of that target. And so the more I talk about sharing, then I talk about expanded time. And so that's why these systems were designed the way they were. But we just want to see how we can inform a Joint Force Commander to protect the force in terms of how we do air missile defense. And so the other piece we added to this was just this idea of how can we use the services and national assets to keep an eye on wherever that came from. There's a tell at that point of origin. And so usually the way our enemy fights is they come up, they shoot, and then they go hide somewhere. So how do we as a joint force, once we identify who shot it, keep an eye on that guy? I want to eliminate that threat. And so we culminated that with a PRISM shot to show the precision strikes missiles capabilities to eliminate that point of origin. Now again, from a scenario standpoint, so we went from competition to crisis, if you will, once you start having missiles fly in. And now we're going to make this transition to conflict. And so for us, that would start, based off of the way we fight, with joint fires. And so how now do joint fires come together to engage these threats? And again, the way we looked at it is, how am I integrating fires? How am I integrating what some people see as offensive versus defense and bringing them together in a coherent manner? And so we looked at a number of systems to see how we can bring those things together. When I envision what JADC2 wants to mean, I see it as this idea of optionality. I want a joint force commander to perceive a threat, and then I want to be able to say, you know what, there's 3 ways you can engage that threat. There's 4 ways you can engage that threat. But give them options so that commander, as they see the current situation that they're in, as they assess their operational environment, as they consider the future in terms of their scheme of maneuver or their concept of operations, they can determine how they want to engage that threat best. It's not always about lethality. Sometimes it's about sustainment of munitions, class 5. Sometimes it's about how we maneuver throughout the battle space. We tried to evolve that idea of optionality to simultaneity. So now, instead of saying, hey, there's 4 options, now let's say, hey, you can do 2 of them at the same time. Now I'm realizing this idea of providing the enemy multiple dilemmas simultaneously. And so we want to explore with that. That's hard too. It's hard to be able to say 2 different services are going to do something similar at the same time. And so again, we're really just trying to progress the force. We're trying to inform where these experiments might have fell short of where they could be, and then provide the joint staff some of the tangibles we need, or identify a capability gap if it was something we couldn't do. But exploring joint fires is absolutely critical so that a joint force commander, again, has options, and then for certain targets, potentially can explore this idea of simultaneity. So optionality and simultaneity was kind of what we were looking at for that experiment. We also moved into this idea of sustainment. And so we did experiments with some of the semi-autonomous sustainment technologies. You probably heard of leader-follower. We started to look at autonomous aerial resupply. We delved a little bit in some of the existing predictive analytics and how we're starting to do a little bit better in terms of capturing the status of our vehicles, maintenance status, et cetera. And so therefore, the back end, the enterprise, if you will, can start to forecast the parts that are needed at the edge. It kind of goes back to this idea of logistics at the point of need at the time, logistics just on time, if you will. So this is really exciting. Sustainment's critical to the joint force. It's one of the things that has to happen. And what we're trying to explore is this idea of, you hear sensor to shooter all the time. We need to kind of start saying sensor to shooter to sustainer, because when we talk about operational tempo, if we're not keeping that as part of the loop, then what we're going to do is run out of ammunition, and then we're going to be all waiting. And so if we really want to inform a joint force commander's tempo and keep the pace, ideas as sensor to shooter to sustainer, predictive analytics, and all the things that our sustainment community can do will be absolutely critical. We started to work a little bit more with our artificial intelligence technologies. So we did a AI-enabled autonomous reconnaissance where we had a number, specifically 4 small form factor quadcopters as aerial platforms, and then 4 robotic ground vehicles. And it's this idea of collaborative sensing. So can I have, it's one thing to have one sensor do aided target recognition and say, I see an enemy tank. It's another thing when a sensor can say, I see an enemy tank. Hey, guy from the air, tell me, is that a tank? Hey, other guy from another angle, tell me, is that a tank? So this idea of collaborative sensing is really powerful. We're also working very I wouldn't say slowly, but we're advancing this idea of off-road autonomous behaviors, terrain. And so it is truly a hard problem to do off-road autonomous navigation. And so last year at PC20, we kind of started with waypoints where we say, hey, here's your reconnaissance. You're going to go from point A to point B to point C. And we allowed those robotic vehicles to take that path. And as they went, they were identifying threats, reporting back, building this common operational picture. This year, we've advanced to the point now where we say, hey, here's your area, conduct a reconnaissance. It's kind of like giving intent. And so those robotic vehicles and their ability to collaboratively sense decided how to recon that area on their own, and then decided how to report back those threats to the C2 node. And then we hope to take that next year and actually do it at night, because in all honesty, we fight at night, and we need to advance these technologies. But everything's about learning. Again, everything we do needs to build off of something else. We executed IVAS-enabled air assault. And so how do we take some of these technologies when it comes to augmented reality and visual augmentation to put it in the hands of soldiers and make some common operations like an air assault better? And so what this kind of composed of is the soldiers using our One World terrain, which is part of our synthetic training environment. Were able to do rehearsals. So they were able to visualize with those goggles the objective they were going to assault, go through the rehearsals under the leadership of their platoon. Then as they boarded the aircraft, maintain situational awareness of that objective. And so in the past, what would happen is, whether it be even airborne or air assault, when that soldier gets on the aircraft, they now have no idea what is going to be on that objective. And so whatever that time of flight is, they're just sitting there thinking through what they rehearsed in terms of actions on the objective, but they don't know what's going on there. Now with IVAS, if there's an enemy movement, they understand what's happening. They can start in their mind to prepare. We had in a previous rehearsal of this, there was enemy actions. The platoon leader on the aircraft was able to tell the pilots, who did not know there was a threat, so they could take an alternate path in order to get to that objective. So it was really powerful. And I'll tell you, just think about this from the human element. You know, you're a soldier, you know, and you're going to get off that aircraft, and in the past you had no idea what you were walking into. You know what you were prepared for, but you really don't know what's going on there. Now you're watching the whole time. And so as that aircraft lands, you already know what you're walking into. You're fairly comfortable with where that threat is. And that's a really powerful thing. There's a human dimension to fighting. It is all about the people that serve. As part of the air assault, a couple of other things could happen. The platoon leader could take control of the aerial assets that were on the objective. So all those reports they were getting were because of a UAS flying over the objective. Now that platoon leader can come in, control it from their ATAC tablet, the technology they keep on their arm, and then start to do what they want with it. So if they see a dead zone, because now I'm on the ground, hey, I'm going to move this aerial to this dead zone. I want to make sure there's not, you know, the enemies across the other side of the hill, et cetera. So that was pretty powerful, even to the point where they can engage a threat with a kinetic munition. During that air assault, so now they're on the ground, they've taken the objective. So now we did this autonomous resupply. So it was an autonomous 60. It's a DARPA program, but we wanted to confirm that we could bring in resupplies. We have a number of ways of doing this, but whenever you talk about autonomous resupply, it's always going to be bound by the weight that the payload can come in with. So that UH-60 can bring in quite a bit. And so if I'm going to have a platoon maintain operations after they seize that objective, they need to be resupplied. And then finally, really exciting is we had a new hoist. So we simulated an injured soldier and conducted a medevac operations with this new stability hoist. So the feedback over 2 decades of conflict, unfortunately, is when we would do medevacs, these hoists spin. Not a very pleasurable experience for someone who's probably already not having a good day. So there's a new technology, a hoist that stabilizes. It comes in very fast. So it's actually faster than the previous operations. And then when it comes up and goes out, that injured soldier is not being spun. We also touched a little bit on telemedicine. So we're starting to bring these are technologies that are in the everyday commercial sector. How do we do that on the battlefield? How do we have our medics the ability to not only just assess and triage, but immediately start to send that back to a surgeon. You know, how do I go, again, we say sensor to shooter, it just rolls off the tongue. Well, what about the soldier to the surgeon? You know, how do I make sure at that point of need that we're doing the best we can with medical care for that soldier? And so that allowed us to start to see how these technologies really do influence and contribute to ground operations. And then the last thing we did was, again, much like in PC20, an AI-enabled ground attack. And so how are we starting to take technologies and put them on more ground vehicles? So we had some, what I would call surrogates for future tanks, as well as optionally manned fighting vehicle, a number of surrogates for us to start putting these technologies onto these platforms and see how we can do artificial intelligence for the target recognition, so they can identify threats at the ground level. How do we use artificial intelligence to automate this weapon target pairing process? So the threat is identified, but before that vehicle shoots, the artificial intelligence tells me maybe somebody else can engage it better. And so therefore, it slews to queue, and maybe another either direct asset, maybe it's an indirect mortar system, can engage that threat better. And then finally, how are we developing that situational awareness? So, you know, the idea is I'm a platoon leader in 2028. I'm a young lieutenant, just came out of whatever my commissioning, you know, maybe I was at Stanford, that made my mom happy. But I'm commanding and controlling not just soldiers and tanks and Bradleys, but I've got these robotic vehicles. I've got some in the air, I've got some on the ground. What's the cognitive burden I'm putting on that young leader? Like, how are they processing all this information? And it's one thing to say, how am I operating these assets? But it's even another thing to say, how am I taking in all this information? I mean, they're identifying targets, or they're telling me they're low on fuel. So we're trying to start to understand how can we do artificial intelligence to bring in that information. Almost think of, you know, we have our staff element. So we have somebody who does personnel, someone who does intelligence, someone who does operations, and then logistics. Well, what if I allowed the artificial intelligence to start taking in that information and building that running estimate for me? So there would be certain points where that leader identifies critical information that they need to know, and then as the machines bring that information together in a meaningful way, it's informing that leader what they asked for. And so now they focus on the fight, they focus on the man on the left and right and how to lead them, and then every now and then, Siri for fighting tells them, hey, this is just happened. This requires your attention. So we're starting to push that, very mature. I'm not going to tell you that we've already done it, but I'm going to tell you that we think it's absolutely critical as we move forward because of just the amount of information that our leaders are going to be faced with. Every modernized piece of equipment is generating data. It's generating something that if we're good, we will learn how to make sense of it in order to make it serve a useful purpose. The other thing we're doing out here that's different specifically is we wanted to run all these technologies through denied, degraded, intermittent, and limited environment, DDIL, right? So it's great if I come out and I run something through its paces and I say, oh, this is wonderful. It's another thing if I realize that there is an enemy who has a vote. And so as we did the experiments, so just imagine every scenario that I just described for you, we ran over a 1-week period. The 5th day, we ran it to failure. I want to break things to some degree so I can understand that point of failure. Because again, it goes back to this data collection. Can I truly understand where it fails? How do I inform my industry partner so that prototype, they can see where it broke? And so we pursued this idea of denied, degraded environments, whether that be denied navigation capabilities, whether that be denied spectrum and communication capabilities, but to take away this idea of everything's permissive and to say, hey, in combat it's hard, and there's somebody who's trying to make sure you can't do what you need to do. And so again, we dedicated 1 day every week to every one of those scenarios I described to start understanding what the threat looks like and what's the threat's impact on our technologies. So look, it's all about learning. So how did we get better again this year? So I'm going to kind of show you what we did in 20 and where we took it in 21, because the only way we will get better is if we build off of what we do. So in 20, we basically had scientists out here helping our cross-functional team directors start to understand what we were seeing, what we were observing, how we need to get better. This year we had units. So we had the multi-domain task force and we had the 82nd Airborne Division. The 82nd Airborne Division, if you're familiar, same team that just came out of Afghanistan. And the idea is, we call it soldier-centered design, right? How do I put a prototype in the hands of an operator to give me some meaningful feedback? You know, the commercial sector uses it all the time. It's called a minimum viable product. All I need to do is get feedback from my customer so I can make things better. The sooner I get that feedback, I iterate. If I fail, I pivot, but I keep improving. And so the idea with these units is I give it to a soldier, I get some idea if the technology works. You know, I get some feedback as to whether or not is the trigger in the right place, is the scope, or whatever it may be. But it's honest feedback from the person that I expect to use this one day. You know, I can't give these guys something they don't want, because all they'll do is leave it behind. And so I'm asking a soldier, and again, going back to my data collection, to answer a question for me of, does the technology work? Okay? Now I'm asking a unit, so now I'm talking about, I got a commander and his staff, and I'm saying, hey, is that giving you a capability? Because that's important. Now it's not just about does the technology work, it's can I integrate it in a meaningful way with how we fight? And those units, those commanders and their staff are giving us that feedback. Yes, this is a capability, this is important, or no, it doesn't. It's a great shiny object, but in the end, I can't do anything with it that's useful to the way I fight. But what's really important is when we take this data collection and we look at how that capability performed, can I scale it? Can that meet an operational need to a Joint Force commander? You know, maybe it can't, because we're going to make investments in these things. And so we need to understand, it can't just be a technology that lends a capability if it doesn't satisfy an operational need for a Joint Force commander. And so all that data collection I talked about is really important as it frames these things and puts it in context for our leaders to understand the investment decisions that we're asking them to make. So we had some advances in
the overmatch we need, but we still have more work to do, because whoever can see, understand, and act first will win.
Okay. Hey, so welcome everybody. My name's Colonel Abadie. I go by Dre if you see that anywhere. First off, I just want to say thanks for being here. Thanks for taking the trip. On behalf of our Army senior leaders, thanks for coming out here to see the joint experimentation in action. We're really happy to show what we can, but just have the conversation continue in terms of the pursuits that we're making. So who am I? So I work in Austin, Texas at the Army Futures Command headquarters. I think officially I'm a solutions architect for all things network, cyber, and artificial intelligence. But my role in this endeavor is about 2 years going now. So I had the privilege of being a leader in the planning and design Project Convergence. And then as the plans shifted down to Joint Modernization Command and they took those ideas and turned them into action, I had the privilege of staying involved. So I'm going to share with you kind of the big picture, not just exactly what's been happening, but kind of the context upon which it all built. So Army Futures Command, for those of you who aren't aware, Army Futures Command stood up a little over 3 years ago. Its purpose was to drive acceleration and progress for the Army's 6 modernization priorities. And in doing so, approximately 4 years ago, so just a year before, we stood up what we called cross-functional teams. And those cross-functional teams were aligned against those modernization priorities. And so a cross-functional team has a really interesting role, almost as an integrator. So they have left and right limits in terms of what they do. The left limit is our concepts and the way we visualize fighting in the future. And the right limit is the requirements document, the way we codify and have our leadership approve a requirement. At that point, our teammates in the acquisition world take those requirements and then field capabilities and deliver capabilities to our units. The Army has 31+4 signature modernization efforts. And so those things happen in a temporal fashion. And so when we talk about Project Convergence, it's the idea of how do I identify the technologies that will enable the concepts? And I have to look at a list of candidate technologies and understand which ones are mature enough to actually come out here in the dirt and experiment with.